Hey guys, hope you all are doing well. And I know it's been a while, but this tutorial actually took me quite a bit of stretch to figure out how to do this. So, the idea for today's tutorial is basically something that I saw on the internet, and it really like intrigued me. So, this is basically what I tried to recreate, where uh, this is a caramel swirl with a highly viscous liquid and some hazelnuts sort of punching through them. I have a few still renders of them as well, and there you go. So this is essentially what uh, we're trying to recreate. Now, the file that I've prepared for this is a big file. It comes with a disclaimer, and this file is gonna be available on my Gumroad as well. So, let's get through it. This is my project breakdown of how I managed to do all of this. So, uh, the way this file is set up is this is actually three simulations layer on top of one another. So the first is going to be a flip sim, which is going to be a fairly low res simulation. The second is going to be a hazelnut simulation driven by the velocity that is extracted from the first flip. And then finally, there's going to be a high resolution flip simulation, right? So let's get started. Now, to start off, I just took a simple box and I just translated that box to zero ground, and I started from there on then. Now over here, what I ended up doing was I just created a simple flip source out of this. I'm not gonna go over the basic flip settings in here, like the basic flip concepts in this breakdown. You can find a lot of data on YouTube that explains what happens over here and why it happens. Now, the when working with this sort of a setup, when I actually was thinking about this, the first thing that came to my mind was that these folds that you see over here, this looks like variable viscosity, and oh boy, could I not have been more wrong. Uh, the way this actually works is that this is not variable viscosity. Instead, this is variable density. And what I mean by that, so if I just split my particles from my flip source, because this flip source actually creates two things. So one, it creates a surface, and the second thing that it does is that it creates this particle group over here. Now, if I split my particle group and I just sort of use an attribute warp and multiply a noise over here, right? This sort of gives me a range from 0 to 1, and then I can map that range from 1500 to 500 using a bind export and set that to density. Now, I've actually created an attribute called density for my flip simulation. So my flip is going to read this density rather than the default density, which is consistent. And this is what the main thing is. This is what creates the folds or the illusion of variable viscosity, right? And I just export that as a group as well. I just export the particles with the lower density as a group, and I just use export both of that into a null, and I use that to run my simulation. Now, if I come over to the simulation settings, it's a pretty basic flip simulation setting. Like it's a pretty basic flip simulation. The only thing that I ch think I that I that I changed over here, or that is important for this specific setup, is so the viscosity was 500, right? And obviously I had a closed boundaries option. My particle separations, as you can see over here, was 0.0035. Um, what else? So this is important. I actually brought my time scale all the way down to zero point 0.1 because I feel like when you're working with viscous sims or when you're trying to get those extra intricate details inside of a simulation, it's really good to sort of lower your time scale and instead, I mean, the other way around could be that I just raise my sub steps to around like 10 or 12, but that just takes a lot of time to cook the simulation. So instead, what I do is I drop my time scale and then I just raise my sub steps by like really, really not that aggressively. Coming into flip solver into particle motion, I added an ID attribute. I enabled age particles. I had receding on. It was set at 20 particles per voxel, 3 for oversampling. This is just something that I experimented with. I don't think there's a hard and fast rule you should follow when it comes to reseeding. Whatever, like it's very scale dependent. It depends a lot on what's happening inside of your flip simulation. So I feel like this is something that you should improvise on a lot. I had vorticity on it, and that is about it. For the volume motion, I had my velocity transfer to apex swirly rather than flip splashy. I had viscosity turned on, and I had density by attribute turned on, so it can read the density that I was importing from my SOP level. Right now, coming into my forces. So the first force that I had was a simple pop angle where I just told Flip to sort of multiply the particles that were less dense, right, with a factor of 0.15. So that way they moved like really, really slowly. And that is essentially what is, creating these folds, like this ridge over here, where one set of particles are moving faster than the other, and they're sort of overlapping, and that is what creates the fold. The second one is a simple pop force, just to add a bit of variance to the whole simulation. And the third one was actually this links force. This is a free Houdini asset. I will link this in in my description. And I feel like it's a great resource to have for your simulation. Like it saves you a lot of time. It saved me a lot of time. I didn't have to set up any custom velocities. You get tons of settings in here. Like you can import a spline, you can import a custom shape, you have all sorts of options. That this is basically pop axis force on steroids, right? Over here you just have these two shapes, but when you come to the links force, you have a lot of options over here, right? You can have custom shape, you can have a curve, you can have all of these forces, you have all of these settings that you can play around with. There's actually a good tutorial that this guy, the guy who made the links force, has for everything that it does, and I suggest you go over that before you run through the simulation. Right. So once I ran this simulation, I got something which looked like this. I believe my viewport won't be able to handle this. Yeah. So I got something which looked like this. Uh, and you can see there's quite a bit of swirling happening over here, right? Now this was supposed to be my low resolution simulation, and the particle count that I had on this was about 4 million, which is, I mean, this is not fairly low, but it's decent. It's decent. Um, yeah. Now, once I had this swirl done, like once this swirl was completed, and I liked what I got out of this. What I did was I actually used this swirl to just clip out the top part of this simulation. And the way that I did that, when I was preparing my particles with my density attribute, I just simply created a color gradient on the y direction, right? And I use that gradient to just select this top slice of my particles, and I call that height, right? And I just use that group over here to just sort of blast that group from everything else. And I use these set of particles to sort of create a custom velocity. Just give it a second, this takes a time. Yeah, I just created a custom velocity, and I use this velocity to actually drive my RBD simulation. Now, another thing that I did over here was because my velocity was sort of my flip simulation, or the part that I sort of extracted was sort of driving this whole thing inwards, right? What used to happen was that my hazelnuts, when I drove them through this velocity, they sort of just, went under the fluid, and I did not want that to happen. I sort of just wanted the hazelnuts to float, or like to stay above the surface. And the reason why I didn't do this with an RBD sim was because I don't know, I just tried to make it work. RBD packed objects didn't quite read the feedback scale for flip simulation. If you don't know what a feedback scale on a flip solver is, that basically just detects buoyancy depending on the density of the fluid. So I just felt like the packed objects were not behaving the way that I wanted them to behave, so I instead you just tried to simulate them separately. Now, for my RBD simulation, I just imported these hazelnut models that I got from I think these were from Megascans. Yeah, these were from Megascans, and I got them. They were free, right? These are the hazelnuts, and what I did was I just imported my container in here, right? Obviously with the density particles group, because I wanted the hazelnuts to sort of spawn in these white areas, and I just used a split node to sort of split. So what I essentially did over here is that I this subtracted my this dense MF group from the height group, so that I got left with the particles that were white and on the top layer. And I just split them, so I got this slice of particles on the top, and I just blasted everything using a delete node and setting the point percent to 99.95, and this gave me about 20 points, and that was something that I was happy with. Over here I just gave them some normals, nothing more. And I added a p-scale value. uh, I added a p-scale randomize over here. And what did I do over here? Yeah, so over here what I did was I just made sure that these particles were sort of flat, because if I come over here, you can see that they have a bit of a variance on the Y, and I just wanted them to start out flat, right? So I just used a point warp and just gave the Y value a zero value. And with that, I just gave them a class attribute and used a match size, translated them back to the point that they were supposed to be at, uh, randomized the normals for to sort of randomize the orientation that they were aligned in. And I just created an attribute over here called W, which is the orient attribute, and I aligned it with the normals. I relaxed the points over here just to spread them apart a little bit, they gave them some colors, and yeah, that's about it. And when I imported that to a copy to points, this is what I got. So I got random orientation. They were aligned on the same plane, but I got random orientation with random normals. And I just used an assemble node, a rest node, pretty basic RBD setup, and I ran them through an RBD simulation. Now for my RBD simulation, I ended up using an RBD packed object, and I used pop advect by volumes and imported the velocity that I created from my low res flip simulation into this whole setup, right? And I gave it this velocity scale was actually tweaked. Like I played around with it, and I found out there was a lot of back and forth going on. Like I had to see what looked good with my flip simulation. So there were times where I, simmed my high res flip, and then I realized that my particles or my hazelnuts were not actually looking good, or they were not behaving the way that I wanted them to behave, or they were lagging behind, and I had to come back and adjust the velocity scale and go back again. And another thing that I did was that I added a pop spin node with this code that I just tried to write myself. This might look complicated. This really isn't. The only thing that I'm doing over here is I'm randomizing the axis, right? This attribute over here. I'm just randomizing that axis data, and then I'm using that access data to just sort of alter my spin speed. And the reason why I did that was if I run through my cache, is that you'll see I get some rotation on my, like a very subtle but some rotation on my hazelnut. And I just felt like that looked cool. I mean, I could have done it without the rotation as well, excuse me. I could have done it without the rotation as well, but I just felt like it looked cool. Now, once that was done, I just imported that into my high-res flip simulation folder, and I just prepared this for collisions using a collision source. Now, one thing that I actually did do on the collision source was, because this was such this was like these hazelnuts were like super small. I think this is probably like zero point 0.1 Houdini units or even less than that. One thing that I had to do was, on the collision source, I had to increase my bandwidth by quite a lot. I feel like this number by default is at 4, so I increased this to 100 because my collisions were not being read well. So the only way I could solve it was by increasing this bandwidth like aggressively. And this transform node I added on my collision source just to try and alter the height of these hazelnuts a little bit. As you can see, if I come over here, and you'll see that they move down a little bit. And the reason that I did that was because I didn't this was like a really slow cache. I didn't want to go back and cache every single time I transformed my hazelnut. So I just used a transform node over here, and I created a reference copy over here, so I can just alter that cache whenever I wanted to. Now, for my flip setup, what I ended up doing was I imported the original container over here, and I just transformed that container to, sort of be thinner this time. And the reason for doing that was because I was going to give this quite a lot of particles. Like my final simulation, it had about I think it had more than 200 million particles. So I wanted all of those particles and all of that detail to stay on the top. Like I wasn't going to show anything that was happening on the inside of the container. So all of those particles which were underneath this layer were basically useless to me. So I just tried to use all of those particles to stay in here. Uh, I remeshed this just to, make sure that my UVs were well. I don't think this was necessary, but it worked. Once that was done, let me just turn on smooth wire shaded. Yeah, I just imported my container over here, and what I ended up doing for my container was that I just used these hazelnuts to sort of get a boolean from that original container mesh, so that when I started my simulation, these points did not these areas did not have points. So that way, my first frame, or sometimes what happens is that if there are points inside of your collision geometry, the simulation can go bonkers, or it can take a couple of frames to sort of stabilize itself. I just decided to get rid of that altogether, and I just imported my collision geometry over here, used a time shift node to sort of turn it into a static geometry, like it's a static geometry, and just gave it a peak node to sort of just sort of inflate it around along their normals, to make sure that this wasn't like colliding with the surface of the hazelnuts. And then I gave this some UVs, and I exported it as a UV container. Over here on my flip source, what I did was I just used the exact same method that I did for the low resolution simulation. The only thing that I changed over here was that after creating my this is going to take some time. Yeah, you can see the point count that's over here. Like you can see the detail that's over here. Like the only thing that I did was, once I added that density attribute, I just transferred um my UVs from this container to my attribute transfer. And I was the only reason that I didn't think this was required at the end of the day. But the reason that I did this was I was actually trying to, UV unwrap my flip mesh. And use this flip dop source. I use this setup to export my dop source. And oh my god, this is going to take some time again. Give it a second. Yeah, there you go. And there you have your dop source. Just gonna turn this to manual and I'm gonna run you through the flip simulation settings really quickly. Now, what I ended up doing was I used the exact same forces that I use for my low res flip sim over here, right? My viscosity was the same. My uh, time scale was the same. Subsets were the same. The only thing that I changed over here is that I added a rest attribute and everything else is in exactly the same. Yeah, it is exactly the same. Now, once this was done, what I did was I got my high res flip sim, and if I just come up here, this is gonna take some time, so bear with me. I think this cache was about a terabyte in total for 300 frames. So this was a big cache. Like this took a while to cache. And there you go. This cache took a while. Yeah, yeah. And this was about 123 million points. Yep, there you go. In all of its glory. Yeah. Now, once this was done, what I did was instead of using a particle fluid surface to mesh this, I was having some problems with the particle fluid surface. I always do. I don't like meshing with that. I just used a VDB from particles, and my voxel size was actually set to half of what my particle separation was. I know the thumb rule is to set it exactly at what the particle separation was, but I just felt like at such a high point count, even if I went, below that range, I was not going to lose out on detail. Instead, I was getting extra detail. And I used a VDB reshape to sort of dilate the mesh to make sure that, I was able to smooth it out, and I smoothed it. I used a mean curvature flow and I then eroded it back. Just pretty standard. This is like very, very standard uh, setup for VDB meshing, and I cached that out because the reading my particles all over again were like it was too slow for my computer to handle, and you can see all of this detail that I was getting. Let me just update this. You can see all of this detail that I was getting over here, right? All of this is because of that density attribute that I created. All of this is because of that density attribute, and it just came out looking amazing. Like I've never seen, I mean, I don't want to boast about myself, but I have never seen a flip simulation look so beautiful. And I just used a VDB smooth on it again, just to, smoothen out the details. Now, here's the tricky part. Like, here's what took me a bit of time to figure out. Now, I was actually trying to UV my mesh, and what was happening was, so what you essentially end up doing is that you have a rest attribute on your flip simulation, right? I showed you that I added a rest attribute on my flip simulation, and I also used a rest node on my source geometry. What you do is you transfer the rest attribute from the points onto your meshed geometry over here, right? If I come here, you're actually using an attribute transfer to transfer that rest attribute from your points onto your mesh geometry, right? And after that, you're using that rest to convert into a vector called UV, and then you're promoting that to a vertex level, which is essentially where your UV attributes are stored. And because like this was a simple UV, I just used a UV transform to just rotate that at 90 degrees, and it gave me this UV. But one thing that I did over here was, because this simulation was so high res, I was not able to use it on an attribute transfer because it would take forever to, load in the cache and then transfer that attribute. What I instead ended up doing was I ended up, you know, using this same simulation as a low res simulation. So I ran this simulation at a high res with a lower particle count. I exported that out. Then I raised the particle count again. I think I think I raised it 5 times or 4 times, and I exported it as a rest cache. And this simulation had the rest attribute stored on there. And this was like loading. This was much faster. Like this was much faster, as you can see over here. I think the point count on this was about 7 million. So like this was much faster to load and to read. And I used this cache to transfer the rest attribute from. You can see this is the flip UV sim. And I use this cache to transfer the rest attribute from, right? And that is what I used for my for my UVs, right? And once that was accomplished and out of the way of, uh, what I did was, let's just let it run for a bit. This takes time. You can see how slow this is. Now imagine if this was going through the high res cache. Like that absolutely, I think it was taking like 3-4 minutes a frame just to read that, right? There you go. You can see all of that detail on there. And I just simply, exported it out as an Alembic after that. So, I mean, that was about it. And what I ended up was with something that looked like this. So, yeah, I really hope you like this tutorial or this project breakdown, guys. If there are any questions that you might have, please feel free to ask me, comment on the video. And like, this takes up a lot of time, guys, like researching and going through that frustration. So if you could just like this video, or comment on it and subscribe if you like the content that's coming through, that would be awesome. Also, this file is going to be available on Gumroad for you guys to download and see and try it out. And yeah,